All right, welcome everyone. Hopefully you're all here to learn about DMS and SCT. My name is John Winford. I lead the Database Freedom team at AWS. If you have been at reInvent for past years, you may have seen me doing DMS sessions previously. I used to be the product manager for the service, so I know a fair bit about it. But I'm joined here today with Chaitanya and Pranav from JobWhite, who are going to take a bit of time and tell you about their particular migration journey that they went through while leveraging, of course, DMS and SCT. So to jump into a bit of the detail about what it is we're going to cover today, we're going to first talk about what it is the DMS and SCT are and how they can help you. Dive into some of the product features, what it can do, different things you may not have thought about using them for, before we go and talk about the JobWhite use case. Now, what is not in that agenda between those two lines is I hopefully have time to do a demo. I feel that all of you have probably seen more than enough PowerPoint presentations already this week, even though it's already Tuesday. So I do know that people appreciate seeing the product in action, no matter what the services you're here to learn about, this session or the others. It's good to see things actually in use, so I'll go through a short demo on using DMS before handing it over to Pranav and Chaitanya to talk about JobWhite. Right at the end, there's just a few last slides on different resources you can use and refer to after the session completes when you'll want to learn more about the product. And if we have time at the end, I'm more than happy to take questions. Apparently now with these new fancy headsets, we're not supposed to do it, yelling out across the room, but feel free to come up and ask us questions at the end. I'm more than happy to spend some time doing that. Now my guess is your agenda is already packed, but if it isn't, here are some related sessions. We do appreciate that it's pretty hard to get to everything you might want to see in a given week, so here are some similar sessions to this one. You can see ours is actually listed. This is just a generic slide we use for anything migration related, but there are some other sessions you can go to if you want to. So let's kick off with some basics about DMS and SCT. What are they? Well, before we talk about what they are, why don't we talk about why they exist? So our goal in developing DMS and SCT is to give customers the freedom to choose the best data platform for their needs. You may have seen Andy Jassy doing the occasional tweet about DB freedom. That's where these products came from. To this point, we've migrated over 200,000 unique database instances. So it's been quite a successful product. One of the key things to note is we do not believe in locking you into one particular engine or another. So with these tools, you can use them to migrate not only between engines of the same type, but also between engines of different types. So you can use these products to go from, say, an Oracle database to a Postgres database, but you can also go from Postgres back to Oracle if you ever wanted to do what I would term a silly thing like that. But again, we don't believe in locking people in, so we're here to give you the flexibility to switch engines. So what is the process overall? Well, I am not a sales guy, so I try not to sugarcoat things in these presentations. Database migrations, it's a bit of a complex process. You don't necessarily want to hand it off to your business analyst and say, oh, go get it done and get it to me by the end of the week, right? There's a couple steps in there, but the tools we offer through AWS can make that easier. So the first step with any given database is to move your schema. So I'm sure most everyone in this room is probably a DBA or has some sort of database background, and all know that database has essentially two main parts. You've got your database schema, which is the structure. It defines what that database looks like. You've got your tables, you've got your procedures, maybe some triggers in there, all of that stuff. That's the database schema. The schema is in turn utilized and filled with data. So you've defined in the schema what a table looks like. Your table might have say a customer ID and a customer name and maybe a customer state. Then you're going to fill those tables with the data. So when you're doing your database migration, your first step is to copy or convert your schema. So if you're going from one engine to an engine of the same type, you can maybe use a native tool to copy your schema, or you can use the schema conversion tool to copy it. Traditionally, I would recommend the native tool. There's not really a reason to introduce any extra complexity, but just know that the option is there. Really, where you're going to use SCT, or the schema conversion tool, is when you're looking to convert your schema from one engine to another. Once that's been done, you use the database migration service to move the data. We'll get into it in a little bit more detail when I'm doing the demo. The database migration service can create your tables for you in your schema, but I don't recommend you do that because it only creates the basic table structure. It'll create the table with the columns and the name and the same primary key, but it's not going to create all the other stuff. It won't do secondary indexes. It won't do foreign key constraints. And frankly, the primary key probably will even have a different name. So you really want to use SCT first to move your schema before you use DMS to move your data. And I'm going to take a step back from that and go, if you're doing what we call a homogeneous database migration, you're going from one engine to the same engine in the cloud, or maybe you're going between EC2 and RDS, you maybe don't even want to use DMS. You're probably going to be better off using the native process for doing that. So say you're going from MySQL to MySQL, you just want to do a read replica. Or if you're going from SQL Server to SQL Server, take a backup, export, and restore, right? That's going to be the simpler way to do it. There are reasons why you might still want to bring DMS into it, and I'll talk about that in just a little while. So as I mentioned, we've had over 200,000 database instances migrated with DMS. We always have to have one of these, we call it a race car slide with a bunch of logos. Essentially what we're saying here is lots of people have migrated and or used DMS for other purposes, like say data warehousing type work, feeding from multiple data sources into a single database, but it's been very successful service. So what are the steps in the migration? Well, you should always have a plan as opposed to just jumping in and doing it, right? So your first step is to determine out of, say, an entire fleet of databases you may have, what are the ideal candidates for migration? Now, there's lots of different ways you can go about this. And again, I'm not here to preach using our tools. If you've got your own methodologies, that's just great. But the workload qualification framework is a product that we advocate using to help identify candidates for, in particular, database refactoring. So if you've got some commercial databases and you're tired of paying Oracle or Microsoft big money for it, Workload Qualification Framework will help identify databases that are potential candidates to move to an open source and thereby much less expensive and more flexible system. Again, these categories are somewhat arbitrary. They're just things that we made up. But in essence, what it means is your category 1s are easy to migrate, very much feasible, shouldn't be a whole lot of work, through to category 5, which are just not, to make up a word, migratable. What a category 5 is, to put it in very clear terms, is probably a vendor piece of package software. So if you've got something like, say, Microsoft SharePoint, right? SharePoint is only going to work with SQL Server. It doesn't matter how simple or complex the database is, it is only going to work with SQL Server. So that's a category 5. Generally, when we're saying potential for migration, these are going to be in-house applications your company has developed at some point in the past. So that's what WQF does. It helps categorize and identify migration candidates, and it's available for use as a template AMI on the AWS Marketplace. One more slide on what WQF can do. It can help break down the effort of your migration project. So in essence, it does this thing we call a cost calculator. What it does is it breaks it down by roles ranging from migration architect, developer, QA, project manager, what have you, and the amount of effort we think for this particular conversion that it's going to take for you to do this. There's all sorts of configuration you can make behind the scenes. You can say, oh, look, my developer, he's a bit more of an intermediate developer. He's maybe not an absolute expert. So WQF will factor in that when coming up with the estimates. And you can also say how many people or how many developers or how many QA engineers you have. And it'll at least give you a high-level sort of project estimate that you can use to help support the business case for migration. Because as I said at the start, we know that migration is not a click button, one and done type process, right? It's a bit of a project. The next tool in the process is SCT, or Schema Conversion Tool. So SCT is a bit of a unique product in AWS. Again, reiterating that AWS, Amazon Web Services, SCT is one of only 2 client tools I'm aware of at Amazon. It is a downloadable, executable, or rather installer, that you can run on your computers. It runs on Windows, Mac, and a couple flavors of Linux. And the idea is that it helps you actually convert your schema. part of the reason we've done it as a downloadable tool is, generally speaking, these migrations are coming from on-premises systems, and it's a lot easier just to work with them locally, right? That's the idea. The first step that it will do is actually run an assessment report. So it'll be for this particular database, how many tables do you have, how many procedures do you have, how many triggers do you have, and how much of this can SCT convert automatically for you. It does other things as well. Some people aren't really aware that SCT can also help convert embedded SQL code. So if you have an application written in Java, it can scan that Java app for you and look for SQL statements and try to convert those automatically for you too, from say Oracle PLSQL to Postgres PGPLSQL. Again, I'm going to be honest about its capabilities. If you have a lot of dynamic SQL in your application code where you're building up SQL statements from, I don't know, a bunch of different classes or strings or what have you, it's not going to do a great job of converting that. But in my past life as a developer, I can tell you that most of the time I've seen people actually have more of like a SQL statement library that gets executed by an app, as opposed to dynamically building much more of it aside from swapping out parameters. SCT will do a good job converting those statements for you. What else does it do? Well, it actually also helps with ETL conversion. So if you have, say, some BTEC scripts in Teradata and you're looking to go to Glue, SCT can help convert those as part of an overall migration project as well. And lastly, I should highlight that it can help optimize a Redshift schema. So, Redshift has been around for a few years. You may have organically grown your Redshift cluster, and it may not have been built in the most efficient manner. SCT can do an analysis of how your Redshift instance is being used, and I'll recommend changes to your schema to work in a more efficient manner. So overall, what does SCT help with? It helps with doing assessments, a bit of planning, maybe not quite as advanced as WQF, but it's very easy to use. It'll convert your schema and code. And actually, one thing I didn't mention is it helps optimize your spend. What do I mean by that? As much as I would love to say that everything out there can go and run on Aurora or open source or Dynamo, I'm a bit of a realist. I know it can't. For those applications I mentioned that have to stay on, say, Oracle or have to stay on SQL Server, SCT can at least try to minimize your spend. What do I mean by that? You can point SCT at your instance, and it'll run a quick scan, and it'll look at the features that you're using on your instance. And say you're doing something like you've got Oracle Enterprise going for your current instance. It might say, looking at the features that you're using in Enterprise, you could possibly move that to Oracle Standard Edition on RDS and leverage the enterprise features or similar features that RDS grants you. So as an example, what do I mean? If you are looking for, say, high availability, and that's why you're using Oracle Enterprise, you could instead think about using RDS Standard Edition with multi-availability zone turned on. Right? So that's kind of the idea. You can say, look, you're not really using anything that's too special. You can save money and at least go to Standard Edition. So that's what I mean by that. Just a bit of a visual. As I said, I will show a demo in a little while, but this is an example of an SCT assessment report. So I know we'd all like to just jump in and do things as technologists, but the reality of it is sometimes you need to present to management what's the effort, what's it going to take to migrate this from, say, SQL Server to MySQL. The assessment report will scan the database and it will give you this executive summary and a bunch of graphs beneath it that say, here's how easy or hard it is to migrate. I'll let the clapping stop for a sec. There we go. So the assessment report is the first step you run, and the other good thing that comes with it that you can see on the right-hand side is a action item list. So for the stuff that did not convert automatically, or rather could not be converted automatically, here are the things that you're going to have to do manually as a DBA or developer or what have you to actually get that schema to move from one engine to another. Other things that our products do, first one then the other. SCT, so earlier on, we talked about DMS being the data mover, right? SCT converts your schema, DMS moves your data. That's for transactional databases. In the data warehouse space, it's a little bit different. You don't actually use DMS most cases in the data warehouse space. You use SCT. SCT has this optional component available in the installer that's called an extractor. And what does this do? This is a local agent that you install near your on-premises data warehouse. It doesn't have to be on the same box. It can be, a server near it or what have you, that will go and extract the data locally from your data warehouse, compress it, upload it to S3, and then call DMS to ingest it into Redshift. Why do we do this? Again, data warehouses, you don't necessarily need to have things leveraging an ongoing replication product like DMS does. You can dump the data, load it in, and it's much better to do it in a compressed format as opposed to trying to stream it live over the wire. I didn't talk too much about that before, but DMS does replicate changes on an ongoing basis. So as you're doing your migration, you can also still be using your source database, and DMS will replicate those changes from the source to target to minimize the impact to your business users. All right, so to migrate, what happens? Well, here are all the different supported sources and targets that we have today. I'm not going to list them all off, but you can see we've got 3 broad categories of information. We're trying to cover all the very common migration sources and targets. I can tell you will see a new target being added very shortly. We are continually changing and expanding it as time goes on, but we feel that we've got the wide gamut of sources and targets covered, pretty much all of the common migration paths that you'd likely to see. So how does it work? Behind the scenes, what happens here? How does the migration process go from start to finish? I know it says on the left on-premises data center and on the right AWS cloud. Don't think of it that way, just look at it as source and target. You could be migrating from an EC2 database already in AWS to an RDS database, or you could actually be going from the cloud back to on-premises. A very common thing we see people do is migrate from a production system and they want to get a dev copy of it back on a local PC that your developers are using or something like that. Remember, we don't believe in locking you in, so you can use our tools to go right back out of the cloud if for some reason your migration to cloud didn't really give you the business results you were after. So you're going to spin up a replication instance. What is this thing? Well, behind the scenes, it's an EC2 box that has replication software installed on it. You don't ever log on to it. You don't have to worry about maintaining it. It's a managed service. We handle it for you. You interact with it through the AWS console, the CLI, SDK, API, however you want. But it's a host that we maintain. Once you get that up and running, you define connections to your source and target databases. As I said, that source and target could be on premises, it could be in the cloud, doesn't matter. Think of this like an ODBC connection string. And then you select the tables, schemas, or databases you want to move. DMS is a logical replication product. What this means is we're not moving things down to the bit level, we are literally querying the information out, transforming it if required, and inserting it into the target. This does mean that you don't have to bring everything. You could bring some tables, you could bring some schemas, you could bring the whole thing, or interestingly, you can even bring some rows in some tables. And this is where people start using DMS for BI solutions, right? You can filter out data, feed it all into a data warehouse, or as part of a migration, you might finally be able to convince your finance department that you don't need the data from 1985, and you can filter out and only have the last 10 years worth of data after your migration is complete. Then away you go, let DMS migrate the data, and optionally keep it in sync from source to target. Now, to clarify on the sync, it is a one-directional sync. We sync from the source to the target. We do not do bidirectional synchronization. Some of you might go, oh, I could set up another DMS task and sync back the other way. People have tried. I don't recommend it. There is no conflict resolution, so you'll get all sorts of interesting behavior. I mean, if you like that kind of thing, go for it, but I don't recommend it. All right, and then you switch your apps over and away you go. So overall, to highlight what DMS does, secure, you can do some assessment. Oh, and I didn't mention it does do data validation. If you want to do data validation, it'll check that the records have all moved across. It's very low cost compared to some of the products out there in the public market, and we give you a lot of different options on source and target. Homogeneous or heterogeneous? Like I said, you can use it for migration from, say, Oracle to Oracle. Probably better to use Data Pump. DMS's real power is going between engines. So that second example, SQL Server to Aurora. One exception I can think of, sometimes the native method doesn't offer you ongoing replications. So say you were going from an on-premises RDS or on-premises SQL Server and you wanted to go to RDS SQL Server. The best way to do that is to take a back file export and import it into RDS SQL Server through S3. But there's an outage. While that migration's happening, transactions could still be happening on your source system. So you could do that in conjunction with the DMS replication feed only, so not the full load, but just the replication to keep those changes in sync. Good ways to mix and match. You can do other stuff, fan out into a microservices architecture. So you've got a big old monolithic system. Somebody thought it was a great idea to put it all in one box, and you're looking to split into microservices because frankly that gives you all sorts of flexibility. You can use DMS to bring data from certain tables into certain other systems, give you those options. Other types of use cases, while you've got your options to upgrade between minor versions if you don't want to have an outage that may happen, or say you want to go and consolidate shards into Aurora. A very common thing a few years ago, if you got a really big system, say it was a MySQL system, it was very common to shard it out. Aurora can handle a whole lot more data than a normal MySQL server can, so you could consolidate those shards all back in with DMS. You can also use it for replicas if you wanted to. So say the given database engine you're working with doesn't support a cross-region read replica. You could use DMS for it. There's a couple caveats on there. DMS only replicates very minor schema changes. So if you added a new table to a schema, that might get replicated across. Not might, it will get replicated across. But if you added a new stored procedure to a given database, DMS will not replicate that across. So, there's cases where you can use it, and there's, other areas you need to be aware of some limitations. Now, I did promise a demo, so that's what I'm going to jump into and just show you guys how it is that the product can be used. And my computer's locked itself, so just give me a second. All right, here we go. And press the buttons. All right, here we go. So this is a live demo. I don't believe in the canned ones. Touch wood, it hasn't bit me yet, but it makes it all sort of fun for you guys to see, is this demo going to work, right? Because anything can happen. I'm using the same Wi-Fi network as you guys are, so if you all start checking your email right now, who knows what it's going to do to me. But that's just what makes this sort of fun, isn't it? So what is this? This is an EC2 machine that I have in the cloud. You'd look at this as your development desktop. Probably the best way to look at it. But we're AWS. I don't have a development desktop. Everything I have is in the cloud. So just think of it the same way. Remember I mentioned before that DMS can move things from on-premises to the cloud, from the cloud back to on-premises, what have you. All of my stuff's in the cloud, but it would work exactly the same way if you were feeding from a source system in your office, on your home network, as long as, of course, you had a VPN set up or a direct connect or what have you. So it all works the same. So first I'm going to kick off and show you what it is I'm going to try to do. So I'm going to launch this tool called dbeaver. It's just a free download that you can use to query multiple different types of databases. Doesn't really matter. Use your query tool of choice. It makes no difference at all. This particular scenario, I'm going to migrate a sample database from Oracle to Aurora Postgres to show you how easy it is to go between database engines. Give you a quick example of what this database looks like. Go in here, connect to my Oracle system. I'm just using a sample schema you guys can all find on the internet called Chinook. Nothing too complicated. You can see it's a media system. Pull some data out, and we've got some records here, right? So it's all about artists and albums and what have you, so you can probably see some very familiar albums listed up there. It's a very basic schema. This is not necessarily representative of your production system, but the idea is all extrapolate just on a larger scale. I did want to show you that I have added a couple of views into this system just to add a little bit of extra complexity and show that not only can your core tables get converted, but so can things like views. So this view in particular, I think you guys can see that what it's doing is just joining the artist table to the album table, so you can see the artist that's responsible for the album, right? So just what we're looking to do is migrate that to an Aurora Postgres system. Now, just to prove to you that there's no funny business going on, I'm going to connect to my Aurora Postgres system. And you can see in here, if I go to schemas, you get nothing in here but the default Postgres schemas, information schema and PG catalog, right? So totally empty system. The first step, like I mentioned way back at the start, is to launch the schema conversion tool and convert that schema from my source to my target system. There we go. As I mentioned earlier, SCT is a free download. You can just go grab it from a website and try it out on dev database first. Don't go straight to prod. Just connect in and see how it works for you. Pretty much the only trick I will tell you about SCT is, for wonderful legal reasons, we could not distribute the JDBC drivers for the different database engines with it. So you need to first download the JDBC driver for your engines in question and just tell SCT where they are. Simple as that. If you didn't know what you were doing as far as which target database engine you wanted to work with, you could do the wizard, and the wizard will tell you how easy or hard it will be to convert to different database engines. We know that we're going particularly from Oracle to Postgres, so I'm not going to do that. You can see that we can also use SCT for data warehouses and NoSQL systems. In this case, I'm going to go from Oracle to Aurora Postgres. Press OK. I'm going to connect to my Oracle system. I've done this before, so it's got some connection string information saved. Previously, yours would be empty, but you can see for security purposes, we don't save the password, right? So I'll just go in here. I've got it pasted into memory. Test my connection. Looks good. And I will also go and connect to my Aurora Postgres instance. Okay. Go in here. So on the left, we have my Oracle system. On the right, we have my Aurora Postgres system. I only want to look at the Chinook schema, so I'll just select this. I'm going to right-click, and I'm going to create a report. It takes a second to get going, and then we get this assessment report that I was talking about earlier. So here we have our executive summary. I know it's a demo database. It's, as I said, simpler than what you're probably going to see in production use. But you can see right here how many schemas, how many tables, how many constraints, how much it can convert automatically. And then when you get into the database code objects, how much of those are going to convert automatically as well. All right, so I will just switch back to the main view. And I'm going to go and convert this schema. Right here, this gives me a nice little warning. And I'm going to go and hit Apply to Database. Now, I'll just show you what happens here. If you click on a particular object, and I could have done this before I applied, but just so you guys can see how it works, I've got my 12 tables. I can click on, say, the first one, and you can see here's what the table looked like in Oracle, and here's the same table create statement in Postgres. Likewise, if I go and I look at my views, go into a view, look at that album artist view I was telling you about. That's what it looks like in Oracle. Here's what it looks like in Postgres. So it does all that for you, the conversions automatically, and again, much more complicated ones as well. Now, before I kick off the migration, I can tell you one thing that's not going to work. If I'm migrating data from a source to a target, I have constraints on my table. So I just need to make sure I drop my constraints on my target, because otherwise, it's going to throw some errors during the migration. So I'll quickly do that. There's many different ways of doing it. You can set things up as a replica and what have you, but I'm just going to drop my constraints on my system. Here we go. I'm going to create a temporary table to store the constraints so I could add them back in the future if I wanted to. That looks like the whole lot. Go in here, and I will just do a refresh. You can see I now have my Chinook schema, my tables, but of course, if we look in here, it's going to be empty because we haven't migrated the data yet, right? So I'll just go get connected to the right one, paste that script in there. I'm going to create my temporary table, and then I'm going to go and drop the constraints. So now that's been done, and you can see it's been done because if I just do a quick refresh here, dropped foreign keys, and read the data, you can see here's all the foreign keys that script dropped, and I could run that and apply them back to the database afterwards. So now that we've created the schema, the last step for me to do is to actually migrate the data. So to do that, I'm going to move to DMS. It's nice, Mozilla. I don't want to talk about that right now. Go to AWS. Oh, look at that. Our website has changed. Funny that. Somebody had a keynote today, I think. I'm going to sign into the console, go to the database migration service, show you that I have just pre-created my endpoints just to save some time. Again, these endpoints are just like an ODBC connection string. So all it is saying, here's all the different connections, but you can use a DMS server to do multiple different things. The single DMS instance could be migrating data from Oracle to Postgres, like we're going to do today, but it could also be moving data from MySQL to S3 at the same time. It just processes migration tasks. That's all it does. So what do I want to do? I'm going to create a migration task. Go in here. I'm going to give it a name. Let's just call it Chinook. We're going to use my replication server. My source endpoint is going to be my Oracle one, and I'm migrating it to Aurora Postgres as a target. What do I want to do? Migrate existing data grabs the data that's there as of when this task starts. The other options are also replicating the changes or just the changes. Okay, start task on create. I'm going to do nothing for target table prep mode. What this means is if the table already exists in the source system, use it. Don't do anything to it. Remember how I said DMS can create a table if it needs to? But I've already pre-created with SCT and done it in a better way than DMS would do it. So that's what this means. I don't have any logs in my database, so I'll just turn that off. And always turn on CloudWatch logs. And you might wonder why it's not on by default. We don't want to charge you for things that you didn't ask to be charged for. CloudWatch is very, very cheap. It's just pennies, not a big deal, but it's still a cost. So that's why I'm turning it on. It's not on by default. You need it on because if your migration task encounters a problem, it's just going to say error. So you need the log to see the more detailed information behind those errors. You might have it off for like an ongoing replication process you've had going for months and no problems, but definitely for migration you want to turn it on. Now the last thing I want to do is define what it is I'm looking to migrate. So I'm going to migrate things from my Chinook schema. I want all tables, the percent being a wildcard, and that's pretty much it. For the selection component of it, the other thing I need is a transformation rule. You guys may have noticed that Oracle, everything tends to be uppercase. In Postgres, everything tends to be lowercase. So all I'm going to do here is add a couple transformation rules to make sure that DMS knows to respect these case differences as it's migrating across. So I'm doing it for the schema, for the table, and then lastly, I'm going to do it for the column. So that's that. And now I just go and I hit create task. Oh, it looks like I missed something. Validation rule action cannot be null. I did not turn. Sorry, what did I miss? Oh, there it is. Thanks, guys. Make lowercase. Make lowercase, make lowercase, create task. There we go. That way you can see it's not a canned demo. It's actually live, right? I'm not just talking to some script. There you go. The task starts creating. I will just, you can monitor it here. There's all sorts of metrics. You can see the latency, how many records are being moved per second, that sort of thing. But of course, the straightforward way to do it is just go back here to dbeaver, and I'm just going to try to read the data into the SQL console. You can see it hasn't come in yet. I'll give it a second or two more. And we should start seeing some records appearing. It's always like, what do you do with this part? Do you tell a little side story? Do you start telling jokes? But the data will flow through. And let me just switch back. Full load. You see it says starting. And there we go. We've got some data. So we have converted the schema from Oracle to Postgres, and we've migrated the data across. Once the data actually finished migrating, you would, of course, go and enable those constraints again that I turned off. And in a production migration, you probably would have enabled data validation during the process as well. But just for quick demo purposes, that's the general idea. And with that, I think I'm going to pass it back to our friends here to tell you a little bit about JobWhite story. If I can get. There we go. There we go back. On to you guys.
Right. Thanks. Thank you so much, John. Let's go with this. So, hello everyone. So I'm Pranav Bhargav. I'm the Director of Engineering at JobWhite, and I manage some of our product engineering teams there. I was helping lead some of the execution phases of our Aurora migration project, which is what we call, which is really our migrating from MS SQL to Aurora MySQL. And super excited to share our journey alongside Chaitanya here. So before we start, I want to go a little bit about JobWhite. Some of you might have heard about JobWhite, but JobWhite is a comprehensive talent acquisition focused suite that offers more depth of data to power predictable hiring results. It's really just making sure that you can have a good talent acquisition function in your system. We have been around for close to 20 years of experience around here, and we have industry-leading features and functionality that we've built around social referrals, recruitment marketing, and so on and so forth. And for all of that, we've been recognized as a market leader by IDC and Forrester Research. And it's always good to be recognized by the analyst firms because that does validate some of the work that you're doing. We are an enterprise SaaS platform with more than 2,000 customers, with customers ranging from small SMBs with hundreds of employees to hundreds of thousands of employees, enterprise customers. With our recent funding, we did acquire 3 best-of-breed recruitment solutions, telemetry for our native recruitment marketing, Canvas for our bot automation and text recruiting, and RollPoint for our internal mobility and referrals. With that, I'll go over some of the numbers because we all love numbers, don't we, right? This is JobWhite is its mission is to power people and company growth. And with this combined platform, we're actually living this dream. We actually impact everyone's life on a day-to-day basis with 100 million candidates on our system, with about 8 million active users. And if you look at these metrics, we have some glitch in our slides as well. So, but yeah, this is where we stand in terms of our impact. And there are chances that some of you would have interacted with the JobWhite platform at some point of time in your entire journey of your job so far. So this is how we'll break down the agenda for the next few minutes. And we're going to talk about the what, why, and the how of our migration journey. And then we're going to obviously talk about the challenges, our lessons. So I'm going to be covering more about the Datastore. What exactly did we convert, which was obviously our MS SQL. What was the size? What were the challenges? And what are the other things that we did to make sure it's a healthy Datastore that we are converting from MS SQL to Aurora MySQL. The next step is obviously our drivers for migration. I mean, I've seen a lot of migrations which are expensive and can go really, really wrong. So you want to make sure you have the right drivers for migration, and you want to make sure you have your product partners, you have your execs buy in into why you're doing it, and also you're held accountable for that. And we made sure that everything is done right and communicated so that we work on this journey with a plan for success. Next part is our migration strategy. Obviously, we leveraged the SCT, the DMS, and how did we actually go through our journey and broke it down into phases to actually make this a phased process, which actually ended up with a very successful outcome of our migration very recently. And the last part is the challenges with our migration. I mean, this is the fun part, right? If it were simple, it's not fun, right? And it wasn't simple because of, if you can imagine, with 20 years of data being built, with a lot of different technologies that we've used, we had a lot of challenges, but that's what made it a really fun project to really work on and with successful outcomes. And obviously, to end with, we'll have some lessons. Hopefully, you can take away with it. We understand that a lot of things are dependent on everyone's data set and everything, but there are some common themes that we encounter, and hopefully, those will be useful for all of you. So let's talk a little bit about the Datastore. So the JobWhite Datastore, our main relational database where we store most of the stuff around all the candidates and applications and the data that you just saw is we had a database size of about 4 terabytes. That's big enough that we ran into some of the issues around our migration. And when we started looking at our data, the first step that, like John mentioned, was to assess that data, right? Is that the right data that you're migrating? Do you want to just take all of that data and just move? Or do you want to actually take a look at it and see is it the right data in the right place? Because over this course of so many years, we actually just to be honest, started dumping a lot of data which shouldn't be in that place. So we ran a few migrations within this entire migration process where we took a lot of our blob storage and actually sent it over to S3 and made sure we had that migration before we actually do the migration. So this was very useful for us, and it was the right thing to do a few years back, but this was a great opportunity for us to do that, and this project enabled us to do that. And obviously, if you see some of we have about rows with tables with about 1.2 billion rows, and we had some fun time migrating all of this data, and Chetan is going to cover a lot around that migration journey that we had. You also see that we had a bunch of queries and functions, and like John mentioned, we had all kinds of patterns of queries with string concatenation to HQL to store procs to everything. Anything that you can think of, we had a version of it in our code base. So that made that migration journey fun, but also we made sure that it's future compatible, where we actually built an ORM in front of everything so that the next time, if we have to migrate, we have a good, healthy system in place. So let's talk a little bit about the drivers for migration. This is really, really important because this really, we started off this project by talking about some of these things with our management and with everyone around who made the decision. So we're going to talk about the infrastructure reasons for doing it. We're going to talk about the scalability reasons. Cost was a good side effect of this. So obviously not was our motivation for doing this, really, to be honest, and security and future readiness of our code base and in general our development process, right? So our current setup that we had was an MS SQL cluster which was hand-built in the sense it was on EC2 instances with EBS storage and everything that was replication setup and everything that we would manage and we would do it by ourselves. We had master-slave set, typical master-slave setup, where we would have one-way transaction replication setup to make sure we could have reads going to our slaves and so on and so forth. And what we used to encounter was, obviously, it was a lot of management that we had to do. And JobWhite, being a partner with AWS and has been on AWS for a while now, we prefer services over servers any day. I mean, this is not our core competency, and we trust Amazon to build the best services possible, and we really want to rely on that. And this was a perfect example where we took Aurora, embraced it, and we actually saw a lot of benefits that we could do that we couldn't actually do with MS SQL, with obviously having our replica set up at very easily within minutes, which used to be a problem early on. Sometimes there were cases where we had to set up replica. It took us close to a day probably to sort of bring it up, right? And obviously, if you talk about scalability, which sort of goes hand in hand with this, is our master, which was our primary bottleneck, right? It would keep us awake at night, that if something happens to our master, what would happen, right? But with Aurora, I mean, we've had instances since we moved to Aurora where our master just switched over and we had a failover, and that's it. It was transparent to our application. There was some gap, maybe a few seconds, where things were not healthy, but that's about it, right? Something that would take days is now easily doable with just a few seconds, actually. And all of you probably aware of all the changes that if you do in a MySQL or even MySQL to some extent with 5.6 and in 5.7, if you have some DDL changes, like a simple thing like adding a nullable column to a table, right? That could lead to take a lot of time, and if you have a replication setup done by yourself, you probably will see replication broken and things like that, right? This is seamless. It just happens in less than a second. The last time I checked, it was less than a second. It's so insignificant that you don't have to think about these things anymore, right? And thanks to the AWS architecture, AWS Aurora architecture to enable this. And like I mentioned, cost, never the primary motivator for this, but it was a good thing that we saw was actually we started seeing a reduction in our costs, because think about it, right? When we want to provision your own servers, you have to over-provision your EBS storage. The last thing that you want is your database is growing, and then you realize, oh shit, we need to actually get our database and sort of make sure we increase our database sizes. So with Aurora, you just pay as you use and things like that, right? So we did see a significant improvement, and everyone was happy about that. But we made sure that our entire thing in this journey, first of all, we modernize our database tier when we say that everything is standardized in terms of our application tier, our infrastructure tier, everything is code and is automated to a point where things just work out of the box. And obviously, like I mentioned earlier, we wanted to migrate our application code to ORM and to make sure that it is transparent next time what query engine is running. It should just be simple code that's just calling our ORM script. Last thing that I want to cover is security. That's definitely not an oversight, but it's something that we get out of the box and we don't have to think about it, and make sure we don't miss it, where encryption at rest, transit, or even automatic backups and things like that are just taken care out of the box, and that's something that we all appreciate. So with that, I'll hand it over to Chaitanya, who's going to talk about the next steps in our migration journey.
Thanks, Pranav. Good evening, everyone. I'm Chaitanya, DevOps Manager of JobWhite. I manage a wonderful team who did a heavy lifting of the migration project from SQL Server to Aurora. I would like to also thank the DMS team and then JobWhite for giving an opportunity to present our JobWhite case. And I also thank everyone sitting in the room for investing your valuable time for learning about our JobWhite journey. So without any further delay, I would like to move further with our project migration. For any successful migration or any migration project, in order to be successful and more transparent, you need to break it into a few different phases. And we did the same. The first one is the schema migration. That's the very initial step when you started working on the schema migration. So until and unless you have a very base schema, you cannot really proceed with a database data migration. So yes, like as John mentioned, we have the SCT, which converts the schema from source to destination, but like it doesn't exactly convert every schema, every possible schema. There are always some corner cases which we need to have a room for it and then try to tune that. And next thing is the data migration, where we actually lift the data from like a source to destination. And next is application migration or application performance testing. So you did a data migration, but how do we know that this data is going to work, or how do we know that we are going to get a expected performance in our destination? Or like, yeah, we know that Aurora is scalable and then it gives a 5x performance, but how do we know that? So you need to have a proper performance testing before you get into the application migration. Next is application migration. Okay, we're done with all the prep work. You did a schema migration, data migration, performance, and you need to invest your time in automation for doing application migration. We shouldn't juggle between the things when you are actually cutting over the data or like a application and missing few steps. So try to avoid minimizing the manual steps and then invest more in the automation. Last but not least, which is the rollback. If you are claiming that project is successful, or if you say that you are ready, you should have a proper rollback plan. Without having a rollback plan, that means you're putting your business at risk. So this is most of the people like they miss this step and then they assume that like they are ready, but they're just like not ready until unless you have a rollback plan. So schema migration. So during this phase, like we just converted our schema, and there are like a few data type issues, and then we try to convert that. And like say, for example, you have like a get date in SQL Server, and you have a date time in Aurora, and you have like a bit in SQL Server, and then tiny int one, which is the bit conversion in Aurora. Like there are a few changes. Like when you are converting a different technology, so you need to be aware of like what's coming, what's the difference between the SQL Server and Aurora, and then query optimization. It's a constant journey, and then giving a knowledge sharing to the team and move across with that. And next thing is the challenges. There are a few challenges when we're doing a migration, which is like a character set and collation. This is the main thing I'm going to cover in the next slides. When you are migrating a data, we started with a journey migrating from SQL Server to MySQL 5.6, and we had encountered few collations and issues. And next thing is about the datetime conversions and then stored procedure functions and then schema validation. This is all like Pranav has covered. Like we need to invest some time on rewriting your code. It's not like a schema conversion tool. It's not like a magic tool that you click on, everything is smooth. We need to invest time on that. And during this journey, I realized the importance of having some kind of a validation tool. Yes, we have this tool like a schema conversion tool or any other tool. We did a migration. We assume that it's going to work, but how it's going to be validated? Are you sure that it's going to work, or did you get an expected result? So we need to invest time on the validation. That's where initially when we started a validation tool, we started with only tables. Okay, we had 2 free tables. Is it got migrated? Yes. We have like some X number of columns for each table. Is it migrated? Constraints, triggers, and row count. We stopped there. We stopped exactly at that point, like, okay, it's working fine. But we missed a very crucial step in the initial phases, which is the data validation. So we know that rows are matching, but is the data is exactly correct or not? We didn't validate it at this particular step. And we just did a data migration. And as I told, every phase is not like we're doing a one time. It's an iterative process. We need to keep doing the same task again and again and again. When we started this journey, like I would like to give a JobWhite use case where we have like around 2.5 terabyte of data, or we started with a 4 terabyte of data. And when we click on a migration, it took literally 20 days. Literally 20 days to migrate from source to destination. And we click on a migration. We waited for like 20 days. And yeah, the migration is completed. Development team just go and testing. And then they just did it, and then they found some few issues. Yeah, this is a bug. Let's go and fix it. And we fixed it. Again, start. Waited for 20 more days. This is practically not, I'm like, we cannot literally wait for 20 days for just doing a simple bug. And it's not scalable. That's where we identified that we need to tune this. Really, we need to tune this, get into the few hours or the acceptable amount of time. That's where we worked with an Amazon DMS team and then found out that there are few tables which we're using as full lobs. That means like it's trying to scan across this row and then replicate it, and it's going to take time. And we see that can be tuned by setting up to the limited lob. That's where like, okay, you find out the maximum row size. You found out it may be like a 1 MB. Just set a limited size, limited lob 1 MB, initiate a replication. That will be much faster. It came from 20 days to 5 days. Still, that's not acceptable behavior. How can we tune further? We did like, okay, we have like around 250 tables, and we break it down to the multiple chunks. Smaller tables into the one task, larger tables into the separate task. That's where we brought it down to like literally few hours, from 20 days to few hours. And during the morning, we used to do all the testing, and then all the development work. During the night, we just initiate a replication, you go home. And tomorrow morning when you come here, yes, the replication is synced, start working, start doing a testing. That's where like we brought from 20 days to like a few hours. And the next important step, which I want to reiterate on this one, because like we missed out enabling the task validation, because when we start validating it, we used to get a hell lot of errors. Honestly, when you do enable the validation, sometime in like 2017 early stages, so we used to get a lot of errors. We thought like, okay, data is validating, and we are seeing like when you enable the validation, the task is heading into the error state. The data is never going to migrate. So we worked with Amazon, and then we found out that at that point of time, it's not really scalable, so we removed it. And then, yeah, application testing, no one has reported any issues. Let's move further. Performance. This is a very important step. We invested almost like a four months just doing only performance testing. We started with our JMeter scripts, and then scaling out like a number of users, 10 to 20 or 100. We're assuming that everything is going to work, but we're really not gaining a confidence that, okay, is it going to really work when you do the cutover? That's where we just went into the war room and then discussed like, what are the innovative ways where we can gain the confidence of the management, or literally we can say that when you do the cutover, it's really going to work. That's why we invested a tool called Go Replay that intercepts the production traffic, and you can capture that in S3 and replay the traffic from S3 with amplification of like say 1x load, 2x load, and 10x load. That means you are actually taking the production traffic and then putting it into the performance environment, replaying it. And it's not like a one time. We did like multiple iterations. We did it for once, twice, and then and I would like to bring out the one more important feature of the RDS, which is the backtrack. With the backtrack enabled, you can say that, okay, this point of time, take a note of it, and you replay all your production traffic. You see that, okay, you got like a 20 queries which are running slow, go and fix it. Then do the backtrack to the same point, exactly the same point where you are enabling the production traffic. Now replay it. That's where you are doing it multiple times with the same traffic, iterative behavior, and then you're able to fix all the production issues. Now we are really confident that when you do the migration, it's going to work. Next is the final step is application migration. That means like application cutover. We invested so much time in the planning and execution for the schema migration, data migration, performance, and application migration. Also, we invested time on the automation. Our entire application configuration is managed through Puppet, and then we did minor changes in the configuration, and Puppet take care of the updating all the configuration in the entire fleet. And we have an Ansible scripts, which is a playbooks where we develop to stop the traffic and then do the cutover and enable the traffic. This literally went into the few minutes, and there are like very minor manual steps during the application migration. This comes with the proper planning and then execution. So we are really fortunate that there are no escalations after this migration, and then the transition was kind of very smooth. How did we gain this kind of a confidence? Just because we know it's going to work by replaying all the production traffic in the performance environment. Without that, we wouldn't have achieved that. We didn't have confidence that, okay, we hope it's work because, you know, I did all the slow running queries because I enabled the slow log, captured the queries, I tuned it. But we don't know. You are tuning only like 5 seconds queries, which are running less than 5 seconds or 3 seconds. What if there are queries which are running 2 seconds and causing a performance bottleneck? So you don't know. You'll know only when you replay with the production traffic. And I would like to summarize with what are the challenges during the migration. Is initial phases is more about like a schema conversion, like when you migrate a schema, there are some default constraints which are missing, and triggers are missing, and there are some XML data types which are not supported in Aurora. So you need to update your code and then make it compatible. And then data type conversion issues like a bit and date time. So you need to convert that to the datetime 3 to get the exact precision of the SQL server. So when you use the schema conversion, it doesn't actually migrate to datetime 3. It just says the datetime. And I would like to bring one more thing, unsupported collation settings. When we started our project, we started with the MySQL 5.6 migration. SQL Server having a collation settings of accent insensitive, case sensitive, and MySQL 5.6 doesn't have any equivalent version. And during our performance testing, we see that our error rates are bumping up, and we realize that there's something wrong with the data. When we looked into it, collation settings are not matching. How do we deal with it? Okay, let's look into the MySQL 5.7. No, that collation settings are not even available in MySQL 5.7. Okay, how about 8? Yes, it's available. But do we have a Aurora 8 MySQL? No. We are bumped. We literally stopped that project at that final state, seeing that I cannot proceed with this migration. We're glad that Amazon team took this as a priority and ported that collation settings from 8.0 to the Aurora 5.7. And we made a progress with this project. And this upgrade part is straightforward for us because like we use all the CloudFormation templates. We just updated the engine, storage engine, run the stack update. So it went all the way to 5.7 in the performance, and then we run the performance suite again, and it's working fine. And finally, we're able to migrate it. And unsupported data validation for emoji characters, now it's not applicable, but during our time of migration, data validation service, whatever the DMS is providing, is not supporting the special characters and emoji characters. And then even though the data is same in source and destination, but it raises a flag that the data is inconsistent. Now it has been fixed. So because of this error, we developed our in-house validation tool to find out like whether the data is correct in source and destination. So we give a table name. Our in-house validation tool verifies actual data. And performance benchmarking. We invested time on our performance strategy to migrate the data and simulate a production load. In our So we use our performance strategy to simulate our production load. That's where we're able to capture most of the issues. And these are the few lessons learned. You need to understand the difference in query optimization. It doesn't actually work in the SQL Server and Aurora in the same way. You need to understand your application data. Trust, but verify. So you should trust your tools, but you need to have some validation whether it's really working as expected behavior or not. Simulate on production traffic, and things will not go your plan. Honestly, because this is such a big project, you cannot plan everything in advance. You need to give a room for changes. That's all. Thank you very much.
Thanks, Chanya. So I'll just finish off. There's a couple more slides. We're not going to go through them. They're just attached for your benefit if you're going to download this presentation afterwards. There's resources if you're interested in getting more information about DMS. Oh, apparently my mic's not working. Working now? Okay. Great. So yeah, we're not going to go through them. There's a few more slides that we've just attached to the deck for you to look at later if you're interested in getting more information about DMS and SCT and what have you. Just links to where you can get more detailed documents and handbooks and what have you. Where to go to follow up after this session if you're interested. So yeah, I'd like to say thanks again to JobWhite for the time today, and thanks for everyone coming along to learn about DMS. If anyone has any further questions, feel free to come up after the presentation. Thank you.
Thank you very much.
Thank you.